Welcome to the Auburndale Public Library. We're here today to show you one of our items in our steam boxes that are available to check out. What's a steam box, you say? Well, a steam box contains a science, technology, engineering, arts, or mathematics item. Basically, gadgets and gizmos and fun things paired with books and resources, like this video, to help you learn how to use the items and what to do with them. See? We have all sorts of fun stuff in here. Today's steam box includes the snap circuits. Snap circuits allow you to form electrical circuits using various conductive components attached to a base grid. The components attach to the base grid, see? And they use electricity to emit light, sound, or move a motorized piece. Each set comes with an instruction book of preset projects to try out. And today we're going to do a few of those projects. So how about for an introduction, we start on project 1. They've started out pretty simple for us on this one. We need a power supply, some snap wires, a switch, and a lamp or a light. Okay, so first we'll try to copy the instructions exactly, matching each piece as seen on the diagram. Each piece is labeled so it's easy to find. All right, so first we're gonna put on our battery on C6. C6. Okay, and we're gonna put this on C2, and we're going to put our lamp socket on C3, 4, and 5, and our switch on E3, 4, and 5, and then we're going to use our jumps to connect them. There we go. So now that we have it completed, looks just like our diagram. Let's flip the switch. Yay! So we have a complete circuit. All right, so we got it working, but what's making it work? Well, like we said at the beginning of the video, we're creating an electrical circuit. Every piece is important, but our energy source is needed before we can begin. And our energy source here is a set of 2 AA batteries, see? From the energy source, we can follow the path set out by the snap wires leading to the switch. And then the switch is what we use to control the flow of electricity once we have everything connected. Just like a switch we use to turn on a lamp, a vacuum, or a computer, our switch is going to allow us to change it back and forth from an open circuit to a closed circuit. Those of you that watched the Makey video may remember an open circuit is a circuit that is incomplete, meaning the electricity is unable to get our load. So think about it. If I take one of these off, it's an open circuit. It's not going to work. So if I put it back on, see, it's not going to work. And if I put it back on, whoops, everything slid. It is now a closed circuit, so it works, okay? So, an open circuit is the circuit that's incomplete, meaning the electricity is unable to get to our load. A closed circuit is complete, meaning the electricity can flow freely and power our load. See? Turning the switch on makes the circuit closed, and turning it off makes it open. And remember, a closed circuit that allows our device to work. So let's skip around a bit and move to Project 11. Project 11 is still using the switch, but the main difference is we're going to swap out the light for the motor. Make sure the positive is the right direction, otherwise it won't work. All right, the motor comes with a fan blade as well. So let's replace the light with the motor and put on the little fan and flip the switch. Are you ready? As you can see, the miniature fan is spinning just like a regular fan would. And if we give it some time, it'll build up some speed. And then when we switch it off, it flies! When set up this way, the fan is blowing air downward. So when the motor loses power, it slows down and begins to stop. That speed rotation of the fan allows it to float off. Okay, so for our final project, let's try Project 12. Project 12 is a combination of both of our previous projects. We'll be using the light and the switch and the motor and the fan blade. Now let's flip the switch. And we hear our motor, right? We don't have the fan blade on. So we are now going to add the light. And put our fan blade on. And now, as you can see, the light is dim. And we can tell that the fan is spinning more slowly than it was before. This is because of the addition of the light. It's added resistance to the electrical circuit. Resistance is a hindrance to an electrical circuit, meaning the more resistance there is, the worse the devices will function. But the question is, can our fan blade still fly even with the resistance? You ready? Aww, it looks like the resistance was a bit too much for our fan blade to take flight. Alrighty, so we've covered a few of the projects from the Snap Circuit Manual, and there's plenty more combinations you can make on your own. Not to mention, there's more than one type of Snap Circuit kit at the library. So we look forward to seeing you guys and gals at the library, and don't forget to check out our STEAM boxes while you're here. Have a great day.